Today, we're going to talk about our project 2, which is the crime graph database. First of all, we're going to start with the design of our graph database. Here we have our graph database schema, which consists of 5 nodes, which are crime, neighborhood, time, beat, and property type. So a good graph database design has a central entity with a finest grain that connects all the nodes and relationship. In our project, this is our crime node that describes all the crime entities in the dataset. Next, we're going to talk about the implementation of the graph database. For this project, we're only going to use a subset of the whole dataset to optimize testing time. We do this by using stratified sampling of the dataset to ensure that the sample accurately represents the dataset. This ensures that the graph database design queries can function well with the original dataset. So there are 3 ways to import CSV files into our Neo4j, which are Neo4j ETL tool, Cypher load CSV queries, and APOC plugins. For our project, we have decided to use the load CSV method because we believe that it is the most suitable method because it is very simple, straightforward, and flexible. And it matches our sample size, which is 1,000 data. And that is a relatively small scale data, so we don't need any complicated tools that Neo4j ETL tool and APOC plugin has to offer. So after importing the CSV files into Neo4j, we are able to conduct analysis and answer questions using the Cypher queries. And I'm gonna pass that on to Natasha.
Okay, now we will be talking about navigation of the graphs to answer useful queries. This is Neo4j browser, where we loaded all of our CSV files in order to conduct analysis. On the left navigation bar here, you can see all of the node labels that we have loaded in and all the relationship types. So Neo4j is able to perform a number of various operations. This query here is an example we'd like to explain. So in this query, we wanted to find the neighborhoods that share the same crime types organized in descending order of the number of common crime types. So we first do this by matching the crime nodes that have a relationship to each neighborhood nodes. And then what we did using this with command and collect distinct command was to create the list of crime types that happened in each neighborhood. This where command ensures that only different neighborhoods are considered for comparison. And with this command, we created a list of common crime types that happened within the 2 neighborhoods, and we sort them into this list. And finally, we return the name of the 2 neighborhoods and the number of common crime types that happened within those 2 neighborhoods, and we ordered them by descending order. This just shows that Neo4j is able to perform operations such as matching, filtering, aggregation, and there are a lot more other operations that Neo4j is able to do. However, in this project, we chose to focus on these ones particularly we have previously mentioned.